On this show, we're tackling a testing question that was submitted to me by one of my audience members, and I brought in an expert. Welcome to the show where we tackle the tough questions submitted by ICT installers, estimators, project managers, IT personnel, and even customers. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and the bell to be notified when new content is being produced? If you're listening to us on one of the podcast platforms, please leave us a 5-star rating. If it's not worthy of a 5-star rating, shoot me an email. Let me know what I can do to make this better. Those couple little steps helps us take on the algorithm so more people can get this content so we can educate, encourage, and enrich the lives of more people. Thursday night, 6 p.m. Eastern Standard Time. What are you doing? I do a live after-hour show on all the major platforms where you get to ask your favorite RCDD, that would be me, your favorite questions about installation, estimation, project management, career paths. I take all kinds of questions. Submit questions early at questions at Let's Talk Cabling for preference. Also, if you would like to be a part of this program, because it costs money to run this program, we do accept Patreon members and corporate sponsors as well. The content's free. It will always remain free, but it does help on the back end to pay for the cost. So as I mentioned, I am on all of the social media platforms, TikTok, Instagram, LinkedIn, YouTube, even Facebook. I'm everywhere. So I get submitted questions all the time. Chuck, what do you think about this? Chuck, what about that? And every once in a while, I get a question that I could probably answer, but I think it might be better if I bring in a subject matter expert because nobody knows everything in this industry. So I got one of them questions. So I reached out to Mike Pennacchi of Network Protocol Specialist, who is a certified testing genius. So we're going to bring him on. Mike, welcome to the show. How are you doing, my friend?
I am doing fantastic, Chuck. It's glad to be here.
Glad to have you, man. It's kind of rare that I have somebody has almost as good as a background as I have. Usually somebody
well, you know what? Got to keep it looking good.
Right. We're professionals. Before we get too much further along, for those who may not know you or know of your company, why give us the 30-second why we should listen to you.
30-second why you should listen to me is for the last 12 years, my company's been delivering the Fluke Network Certified Cable Test Technician Program, where we certify people on using the Versive line of products from Fluke Networks to certify copper and fiber networks. So that's what I've been doing, going out there and teaching people how to set the test up, run the test, and interpret the results.
A lot of people, I think people are really well versed at running the test because you just really like hit the auto test button, right?
Yeah.
The two big areas that they, in my opinion, maybe you can expand on this because you probably have more knowledge than I do in this. The two biggest areas that they fall down on is the pre-testing procedures and the interpretations. Because if they get past that whole, if they get to a fail or star pass, a lot of technicians, they lock up and they don't know what to do.
Well, one of the things I start every class out talking about is that we're doing certification. I do training on a variety of different products for a number of different manufacturers. And one of the things that we see with tools like the Fluke tools and other, fiber and copper certification tools is we're doing certification. And I always like to make sure everyone knows that certification is a process of taking a very accurate measurement and comparing it with the standard. And so one of the examples I give is I couldn't resist. I had to go out, I bought this $28 optical power meter because, I wanted to see what could I get for $28. And the first thing I did, I hooked it up to a switch I have in here, and the signal strength was about half of what I expect. And so knowing that that wasn't correct, I looked on the back and it says, hit these buttons to calibrate it. So you can adjust it. And once you adjust it, the measurement's okay. But here we have something that doesn't start out taking a very accurate measurement, and then there's no standard to compare it to. So we don't get a pass or fail. So if we're going to do we can do measurement, but if we don't have a standard to compare it to, we're not going to do certification. So, like you meant, getting both those right, getting it set up so we're taking the most accurate measurement possible, and then making sure we're comparing it to the right standard. Because the best measurement in the world compared to the wrong standard still is going to give us garbage.
And that's what most manufacturers are looking for if they're looking to give you a warranty. They want you to do a certification test.
Yep.
And I swear, it was almost like listening to myself when you're talking about certification. I was like, man, that sounds like me teaching a class. Because I always go through certification versus qualification versus verification. Those are three different tests, three different testers, and they have three different purposes. Well, some of them overlap, but you don't necessarily want to go out to your truck to go get that, that super expensive certification test, or just a test for the cable. It's not working when you got a continuity tester in your backpack, right?
Exactly.
So there's reasons for everything. So I brought you onto the show. First, I want to talk about some questions that we got. So let me go ahead and bring up the question that this person submitted to me. Now, share the screen. And here comes this question. He says, Chuck, I've gotten 2 test results that I was not able to fix. The first one ended up being a cable, even though it said the connector was bad. So I went by the analysis, which showed the failure somewhere between the connectors. I then cut out the failing cable in half at the mark that Fluke was showing me and retested both. And of course, the other end, the other failed. The other one passed the good side. So I concluded I had a bad cable. Since there is no physical damage, the cable was belted in 6A. There was a belt in 10GX 6A key connect jacks. I don't think the cable and the connectors really have a play in his test results here, because Belden's one of the better manufacturers. So they're not going to really give you any issues. So let me pull up the first screen that he got. And why don't you tell me what he's seeing with that screen?
So what happens is when we run a test, in this case, using the DSX, either 5,000 or 8,000, I'm not sure what she was using on this. But when we run that test on the copper cable, it's going to go through and it's going to compare that cable to whatever test limit we selected. So in this case, it exceeded the near end crosstalk for that test limit. So once we exceed one of those parameters, or we're close to exceeding, and that is, here we see a fail. I think we're going to talk about a marginal pass in a little bit, but in either one of those cases, the tester will run a number of diagnostics. Now, it's important to note that the performance graphs that we typically get at the end of the test show us how that cable performed at a variety of different frequencies. Well, in this case, what the tester does is it runs the HDTDR and HDTDX, and these are the high definition time domain reflectometer and high domain crosstalk. And this is kind of like an OTDR for copper, in that it now allows us to look down the length of that cable and identify where that near end crosstalk is coming from. So when we see a message like this, what the tester's done is it's identified that the majority of the near end crosstalk is coming from the connector that's closest to the main unit. Now, this doesn't guarantee that that is the only problem with the cable. With this tool, what the fault info does is it prioritizes the fix. And it says, look, replacing that connector, probably going to fix your problem. Now, if the cable was really a problem, it would say replace the cable, because you could have a bad connector, but if the cable's bad, it's not going to recommend you replace the connector just to come back and say, oh yeah, really the cable was the issue. So in this case, the first thing that we'd want to do is go in and check that connector, make sure that the twist was maintained, make sure that they use the proper category of connector for that particular cable.
You say twist, and that's here's the thing in the TDMM, right? It says that you can untwist up to 1/4 of an inch for Cat 6A, 1/2 inch for Cat 5E or Cat 6. And a lot of people, they interpret that as jacket removal, but it says untwist. It doesn't say jacket remove. Now, a best practice is to take that jacket all the way up to the point of termination. That way, you're well within those limits. And you and I were talking before, and that's kind of made me think of this, because you're kind of like I am. I'm a testing geek. I love testing. I took a 100-foot piece of cable and I terminated T568A and I tested it. I cut the ends off. I terminated 568B. I tested it and I compared the two together because you always hear A performance better than B, B performance better than A. A does perform better. Tiny bit, not enough to make a difference, not enough to make a difference. But, so you were talking about, you did some stuff like that as well. Have you ever done untwist and done repetitive tests to see if it's affected those test results?
I have, and it does. Absolutely, it does. Now, one that, if it's outside the scope of this time, I would be happy to join on again, and that's MPTL. Oh. And so MPTL is a huge one for me, because what we find is that, like with the Fluke tester, there's one test that we can do that uses the channel adapter. And I give an example. I took a piece of cable, and it's sad looking at it, but I untwisted about 6 inches and put an RJ45 crimp-on connect plug on there, and it will pass the Bixby single connector permanent length, modified single connector permanent length. It'll pass that. But when we do the MPTL on it, it won't. And so what we find is that for all of these tests, it is so critical that we be able to measure that near end crosstalk right there at the connector. And our channel adapters aren't going to do that. And it's just part of the way they're built. But yeah, the untwisting. And in fact, another one that can get us if we have crimp on RJ45 plugs is that when you look at that plug, you've got 4, 5 in the middle, and you got 3, 6 right on each side of it. And it just, you see why those field terminated jacks become so important when we want to get to these higher data rates and so on, to help eliminate that crosstalk right there in the plug.
Especially for, like Cat 6, Cat 6A.
Yep.
The field termination plugs, I think, are a way better option. You want to start a heated conversation on social media? Ask them mod plug or field terminated plug. You'll get an argument. And another one too is pass through mod plugs versus the old style mod plugs. That's another heated conversation. And I'm going to get some. I'm going to crimp them and test and stuff. My concern with the pass throughs is you got bare copper hanging out the end of that mod end, and I'm worried about power over Ethernet.
Well, and so there's another one. I went out and I bought a $25 1,000 power microscope. Now, is it really 1,000 power? I don't know. But what's kind of cool with this is that I can take and put things underneath there. So I'll put fiber, copper, and I took, and one of the cabling companies I've worked with over the last few years has a line of pass-through jacks. And in fact, they just did a great write-up on things that they found with those and whether that's really a problem. But I took a picture of the end of that. I terminated it. And one of the biggest issues is which tools you use to terminate those pass-through jacks. Because if you get the proper tool that shaves a little bit of that plastic off as it's cutting off those conductors, what I noticed was the conductors actually retracted a little bit, and that there was a little bit of insulation sticking out of the end. And so I think there's a number of factors. One of the things that they found too is that when you start getting crimp-on connectors that are designed for a larger diameter conductor, so depending on what size those conductors are, you can end up with some play in there that can cause some issues.
Absolutely. Okay, so shifting back to me talking about testing, my ADD kicks in, right? Right. So getting back to our conversation, so that guy failed in the end crosstalk, right?
Yep.
I thought I read, because I'm running a study group right now for a bunch of RCDD candidates, and I thought we read a few weeks ago that near-end crosstalk was limited to the first 60 feet of the cable for as far as measuring. Does that sound right to you?
Well, for that measurement, yes. What we're looking at though is when we shoot that, we're looking at it along the entire length of that cable to see where that's occurring at. And so that's going to help us identify, it has less impact. The further away we get, that attenuation kicks in, right? And so what we find out is the further away we get from the at each end, less crosstalk we're going to have, because that signal starts getting attenuated as it's going down the line. And that's why, that twist, those connectors becomes so key, because that's where that strongest signal is in that cable. And then when we get into things like gigabit, we're transmitting and receiving on all 4 pairs. So where with 100, 10 or 100, we might have been able to get away with, depending on which pairs are untwisted and so on, some of those things. Now that we're transmitting and receiving on all 4 pairs, that all becomes even more critical.
Yeah, that's when you start getting into alien crosstalk testing and stuff. And,
Yep.
And how many times have you seen people get requested to do alien crosstalk testing?
Never. I mean, I run a poll every time we do a class, and there's 2 questions I always ask. And one is a marginal pass a pass? And I think when we get to talking about marginal passes, we'll talk about that one. But alien crosstalk, if we go in and look at the NCTIA requirements, we see that for compliance testing, alien crosstalk is required. But when we find out what really goes on in the field, nobody ends up really doing it.
Right.
And so one of the things that I always tell people is, as with everything, before you take on a project, it's good to have an understanding with the customer what you're going to do and what you're not going to do. Because doing alien crosstalk testing is a very time-consuming process. And if the customer came back and said, hey, look, you said that you were going to test this, and NCTIA says to be compliant, you have to do alien crosstalk, as a contractor, you wouldn't want to get stuck with having to do alien crosstalk testing without having that in the estimate somewhere. So sometimes it's hard to have those conversations, but it's always a good thing to talk about, management of expectations ahead of time.
I'm glad I got so excited when you said estimation, because I bring that up in every single class. We talk about alien crosstalk testing, not because we think that the students are going to be doing them, but we want them to be knowledgeable. So if they come across it, they can have a conversation with the customer about it, right? And because you're doing 6 round 1 testing, and I tell people, okay, well, if you got a requirement in your scope of work, that you got a 100 cable project, and your scope of work says you have to do 10% alien crosstalk testing, how many cables are you testing? And nobody ever gets that question right, because it's not 10 cables, it's 60 cables. And as an estimator, you need to pay attention to that, because you're going back and retesting 60% of the cables that you had estimated a project. If you don't have it in there, your project's taking a hit on the finances. So I'm kind of glad. Yeah, I was kind of glad to hear you say that. So when somebody gets that near and crosstalk fail, what steps should they do after they get when you look at their test and it says fails because near and crosstalk? What steps should they do to try to remedy that?
Well, see, and that's where, like in our classes, we go through, okay, now what's next, right? And that's where we really try and differentiate, getting that diagnosis from the fault info versus now, how do we really dig in there and troubleshoot it? But one of the things that we look for is when we go in and we look at that high definition time domain crosstalk, it's going to show us a percentage across that link. And when we look at that percentage, what we're looking for is a value of less than or equal to 35% at connectors if the link is over 50 feet, and 30% at connectors if it's under 50 feet. And so that's a number we go by to say, hey, look, if we're seeing over 35% at that connector, that is why that tester is calling that out. Now, I mentioned before that the tester will prioritize the fix. So the tester may go in and say, you need to fix that connector that's closest to the main. But when I look at that HDTDX, I always go out to the other end as well to see if it's over 35%. Because if it is, we're going to fix that first connector. And then when we run it again and it fails, it's going to pop up and say, hey, that other connector's bad too. And if a lot of times, if somebody isn't doing the right workmanship on one end, could be they're doing the wrong workmanship on the other end as well. But, I look for that. Now, I had gotten some cable from a manufacturer, and I tested it and I said, this didn't pass. And they said, well, you just didn't put the connectors on right. I almost, it's like, those are fighting words, right? I'm going to get on a plane, I'm going to crimp something, and it's not going to be the connectors. And and so what we were able to show is that the near end crosstalk failed all the way along the length of the cable. And in that case, within the cable itself, we're looking for a value of 10% or less. Now, if we see a value of more than 10%, that could be where somebody, you know, I still have one of the old cable tie guns for crimping down cable ties. We can get cables crushed on J hooks by having too much, you know, cable sitting on top of them, going over a sharp edge. So if we have one or two of those, may not be enough to cause it to fail overall. But what we're looking for along the cable is that our near end crosstalk doesn't exceed 10% more than 4 times. And so if we look at that, we see that it's constantly exceeding that 10%. That's a good indication that the cable was damaged during installation. Somebody drug it over a sharp edge. They pulled on it too tight. It got flattened somehow. Or if all the cable's bad, maybe it's a manufacturing defect. And that's why if we were to go back to alien crosstalk, one of the things that is a good idea, in the alien crosstalk testing I've done, oftentimes we see that the patch panels can be a big source of alien crosstalk. And where we really see alien crosstalk problems these days is where people are running N-base-T, 5 gig over Cat5e, because Cat5e was never designed to run that sort of data rate. So you start putting 2 of those cables right next to each other, especially in let me see if I grab it without breaking anything here. You know, you get one of these patch panels that has the 110 punch downs on the back. These things were never designed to support frequencies that high. So maybe it says it's a Cat5e, worked great for Cat5e, but now you're trying to run 5 gig across it, and you start getting a lot of crosstalk in the connectors. And so if you're doing a big installation, hey, test the cable, test a sample of cable before you pull that cable in. Terminate it. Do an alien crosstalk test on that. And so you get a good idea of, is this patch panel is that compliant? Is that going to work okay? And if I grab out my cable comb and I get that stuff looking like a pipe running through there, is that going to be an issue?
I've got like 17 questions in my head right now. I hope I remember all of them. So you mentioned test a piece of cable. When I used to work before my training days, I've been in the industry for 40 years. So before my training days, I got 30 years of actually designing, installing, and certifying cable. And I used to work for one of the largest cable contractors in the United States. I won't say who it is. They know who they are. And one of our processes was, if you had a project that was more than 100 cables, not only did we, because normally we tell you, look up the NVP to put the correct NVP in the tester, right?
There you go, yeah.
But if you had more than 100 cables, it was our standard procedure that you had to go in and do the bench test for the actual NVP, because there's an old adage, don't buy a car that was built on a Monday or a Friday, right? And the reason they say that is because on Fridays, people are thinking about the weekends, they're not tightening bolts down all the way. On Mondays, they're hung over from the weekend, right? So the quality can dip on the stuff that's made on Mondays and Fridays. So that's why we said, field test a batch, a piece of the cable for that batch, and then use that value to test all those cables. That way we knew we had the most accurate NVP for that cable plant.
Absolutely. And, and that's one that, with the Fluke, with a lot of those tools, but, specifically with the Fluke that we look at, we can measure NVP, and we just have to have a known length of cable. And so we always like people, hey, look it up, get the manufacturer's number. Now, we find that with ANSI TI 1152A, we can, go over a little bit, 10% on the length of the cable and still pass. But that's where that insertion loss comes in too, is oftentimes you can try and game NVP. And I've seen people do it. You can see where they adjust NVP, try and get those cables a little bit shorter, but you can't game insertion loss. That's going to get you in. And when you start getting out to 295 feet for a permanent link, you really start seeing you're working right at the edge of that insertion loss.
Every single time it's going to nail you. every single time. I'll tell you something else they did, just to get my ADD kicking in. And I'm sorry, my puppy's in the background. Dad, I want attention. Another thing that you'll get across is when you get a technician who's not well trained. And when I say not well trained, it's the company's fault for not training that technician, right? Because
Right.
you get them a very expensive piece of test equipment that does a lot of things. And if you don't take the time, invest in them to teach them how to run, you're going to, what's that saying? Garbage in, garbage out, right? And that's how the thing
Absolutely.
goes. So if, when they go to test that cable, they get it failed, they don't know how to fix it. I've seen this more than once. They'll take off the permanent link heads and put on the channel heads to get the
Oh,
pass. And then they submit
okay.
for warranty, and you'll have like 95 cables that were tested permanent link, 5 were tested for channel. Well, that's automatically going to raise a red flag with me. I'm like, I'm going to reach out to you and say, why did you test those last 5 permanent with channel? I already know why you did. I'm just going to see how honest you are.
And I ran into exactly that thing. I had a company, they said, hey, can you go through the Linkware PC result test report with us? We want to know what we're looking at, because our job is to review that report when people submit it. I'm running down through there and I see channel adapter pop up for a few links. And so what I noticed was that the links that had the channel adapter were all over 295 feet. So what happened is they had to run a few links that were over the 90 meter permanent link limit. And so it wouldn't pass. So what they did was they put the channel adapters on there. They stuck a patch cord in and they ran the test, because channel is going to let us get out to 100 meters. And then they got their green check mark on the report, said that passed. So I said, that is deception. And so it's one thing to go to a customer, and this goes back to management of expectations with the customer. It's one thing to go back to the customer and say, hey, look, we failed this. The only parameter it failed on was length. It passed near and crosstalk, back return loss, all that. The link is longer than it should be. But from everything we can see in here, it is going to work. And just admit that. But to change the adapter, to insert patch cords that aren't going to stay in that link, that is an invalid test. And and there's times I had somebody contact me with some test results. They had some Cat 6 links that would not pass. The pull boxes had actually been covered over with concrete. These links were never going to come out. And what we did was we said, what are they going to run on there? Well, gigabit Ethernet. So we, using the Linkware PC software, we recertified those links to gig. So we were able to say, okay, that they won't pass Cat 6, they will pass gig, and that's what you're going to run across there. So sometimes you have to be a little more, you have to be practical about what it is that you're doing versus being very strict on,
Exactly.
But this was all done with the permission of the customer.
Yeah, it's all about being upfront. And some manufacturers will still give you a warranty even if your length exceeds the standard maximum, as long as all the other tests pass. Some of them will still give you a warranty on that. But you got to be upfront. And like my dad's brilliant man. He always used to say, integrity is not when people are watching.
Yep.
I was like, and he used to tell me these little quips all the time. He's like, Dad, you're stupid. Leave me alone. I don't know what you're talking about. But now I reflect back, I was like, that man was a walking genius, right? So let's look at this from a customer's perspective, right? Because you brought this up, and I want to talk about this. The customer receives they've got the Linkware software. They get the test results from the contractor, right? And they look through it, and you probably heard the same thing. Your instructor, you hear this. Oh, well, if it doesn't pass, you test the cable right next to it, and you just change it with the number of the new one. I've heard that more than once. And I guarantee you probably heard it as well. From a customer perspective, can they find that?
The thing you would see, 2 cables are never going to be exactly the same, right? And in fact, there's capabilities within Linkware to overlay some of the graphs. And so I know that Jim Davis there at Fluke Networks, he has shown me where they've overlaid it. And in that case, it becomes readily apparent that somebody is taking exactly the same results. We're never going to get, no two cables were ever installed so perfectly the same that you're going to get exactly the same results off of both of them. But you bring up a really point on results, and that is that a lot of times people provide the results as a PDF file. And if I have somebody contact me with test results that they have questions about, or they go to Fluke Networks and they say, hey, I've got some issues, here's the PDF, they'll go, no, not interested. I want the FLW file, because anybody can download Linkware for free and use it to take a look at those results. And that FLW file gives us so much more information about what's going on. If we have something that's marginal, that fault info will run and we'll be able to see what's going on with the link. So we can go in there and really take a look at what exactly is happening. And if you have the FLW file, I've brought up recertification, but once we take a measurement on a cable, we can compare that measurement to a standard that may not even exist at the time the cable was run. The example I use is, let's say I went in and a number of years ago had installed a Cat5e installation for a customer and done all the testing and saved the FLW file. That customer comes back later and says, we're putting in access points that need 5 gig. Will this support 5G base T? I can pick all the links that they want to run it on, hit utilities, recertify, and it'll tell me immediately whether those cables passed. Because when the measurements conducted, like for Cat5e and Cat6, even though the test limit for Cat6 stops at 250 megahertz, we go beyond, for insertion loss, we go out to 350. So then that way, we're able to go back and compare that to a standard that may have a higher frequency requirement. We have the measurement. Right. But it also means that if somebody says, hey, will this run PoE? If we didn't run loop resistance unbalanced within a pair and between pairs at the time we ran the original test, we can't tell because we have to have those measurements for that cable.
Gotcha. Very cool. So another question popped in my head, because you mentioned about running cable through J-hooks and it looks for more than 4 events. One of the things that I've been taught many times in Big C classes, and I teach in my class as well, is a phenomenon called harmonic disruption. Okay, and it's defined as an event happening on the cable at exact increments, right? So you got J-hooks mounted in the ceiling every 4 feet, every 5 feet, whatever number you pick, and then you promptly overload the J-hooks, so the cables on the bottom get crushed at exact increments, right? Is that what you were talking about when you were saying that you're looking for 4 events?
Yep. Yes. And so it could be that the events are because, one of them I found was that the machine that was twisting pair 4 was not twisting it consistently. And it was interesting because we tore the cable apart and it was not perceivable to your eye. I mean, you couldn't look at that cable and say, oh, this twist is way off. But it is so critical that we have a consistent twist along that cable, that because then we start running into things like return loss, where we're getting too much reflection coming back on that cable, crosstalk because conductors are close to each other too often.
When you're analyzing test results, how often is it when it's actually a cable manufacturer problem, not an installation problem?
Very, very, very rarely. I mean, that's a really rare thing, because we expect that the the actual manufacturing facility is going to be spot testing cable. We expect that the manufacturer is going to be, that whoever's putting their name on it is going to be testing the cable. We expect that somebody along the way is going to be certifying it as they're installing it. It's going to come back and say, hey, there's something wrong. Every one of our cables is failing. And so it starts giving you an idea of, how many people are really testing these installations that they're putting in, and, who's watching this, and what are the methods and processes that are being used along the way, and are people testing it properly?
Yeah, well, that's one of the battles I'm fighting all the time right now, because my goal is to educate, encourage, and enrich people, because I want people to not have to go through all of the mistakes that I made. I'm trying to help them
Right.
to avoid making this, because I want them to be set up for success. That's why I'm trying to get more people in this industry. And one of the things that I argue with people all the time is they're like, when you talk to them about certifying a cable, well, why should I certify a cable? No, it passes continuity. I'm like, if you're a professional, you need to be certifying the cable. But the first response is, well, I don't want to go spend, let's be honest, Fluke. They're the IBMs of the testing world, right?
Sure. Yep.
If you go all out with the top of the line Fluke machine, that's $20,000+.
Absolutely.
And a lot of people who are new starting off in the industry, they don't have that kind of money. So they're like, no, we don't certify cables. I'm like, okay, continuity only tells you if the bears are in the right order, if you get continuity. They're not going to tell you how it performs with crosstalk and return loss. No, it doesn't measure those things. And those are things you might get continuity, but if that cable is running close to a fluorescent light fixture, or you got two high frequency cables and you get an alien crosstalk amongst them, you're not going to catch that with a continuity tester.
No.
Yeah.
Nope. And that's where things like transverse conversion loss really start coming in with, maybe you don't need to run it on every cable, but having a good understanding of how that cable, how susceptible that cable is to outside noise. Right. Is this cable going to perform well? And, and especially with things like industrial Ethernet and so on, where you have a, potentially noisy environment, you want to know that that cable is going to perform well, because I've spent my career trying to solve the finger pointing game. And I mean, a lot of my career has been spent in doing packet capture and analysis, slow applications. Why is that application not working right? And at some point, when something doesn't work right, they're going to point their finger at you and say, it's the cabling. And what you want is that document that says, hey, look, this cable met the standard that we agreed upon at the time we installed it. Because otherwise, how do you go back? And it's tough to go back years later or a year later when things could have changed and be able to prove that it wasn't you that caused that problem.
Oh, absolutely. That's why, I've got a list of 146 pro tips. And pro tip number 1 is document, document, document. Because it's critical. Everything revolves off that. And when you're certifying, you're documenting that cable's performance on that day. And if you pass it, then you're good to go, right? And we can argue about whether or not you charge the customer for certified test results. We could argue that all day long. But right. if you're a professional installer, you need to be certifying your cables. Whether you keep them results for yourself, just to know that you did it right.
Yep.
And then for CYA, right?
Absolutely.
Your background, you cover your derriere, CYD. Yeah, cover your derriere. Yeah, that's it.
Well, and as a customer, it's important that you recognize that certification is an important piece of it. And I think that, all of us, we won't do something unless we have to in most cases. And so if a customer comes back and writes that into the contract that says that you will certify it, then they know that that's going to cost them a little bit more, because there's additional time. We go back to the estimating, there's additional time. And whether you spend that money on a tester or whether you rent a tester for the project, it is, or you have somebody else. I've got a few people that have been through our training they go back in and they do the certification for the contractor to say, hey, look, we'll do the testing, we'll give you the results for this amount of money. So you don't have to know all the ins and outs of the tester and so on.
Yeah, that's one thing people don't understand is you can rent testers.
Yep.
And there's several companies out there that rent them. Rentelco was one, and there's a bunch of others.
And as an instructor, I mean, that's because I always tell people my goal is to make them the best network analyst or best cable tester they can possibly that they want to be. And I can't, you can only take somebody as far as they want to go. But it's once you've instilled that in somebody, hey, let's go get the tester. and let's see what this looks like. How much does, that untwist look?
Right.
Last year, I bought a fusion splicer. Am I out installing cables all the time? No, but I've gotten more use out of that, building different cables and so on. At first I didn't even look up how to splice it properly. I just started doing it. I got fat splices and I got all kinds of issues. And it was neat to be able to go back in and show, what does that look like on the OTDR? What does that look like on the OLTS? And one of them, I had another instructor in one of my classes, the one never to demonstrate is what happens if you have too much alcohol on the fiber. He said it'll start a fire inside your fusion splicer. He said, and then you got to send it back in to get it clean. So he said, don't demonstrate, because I learned from experience on that one. Don't demonstrate that.
So let's look at a couple graphs, and
Yeah.
let's give you your reading. Let me click share screen. Since you were talking about OTDRs and stuff like that, so let's because that was one of the questions that that person had asked me. He says maybe you should do a show on how to read a graph. So let's pull up a graph. Okay. So when when a technician is looking at this graph, what is this graph telling them?
So what happens in this case is the tester takes measurements of near-end crosstalk between the different pairs at a number of different frequencies. So one of the documents, and I think people will go, oh no, he's not really going to talk about the limit lines, is he? But if we go out to the Fluke Networks website, you can download the limit lines, which is 302 pages of test limits. And what we find is it shows for each one of the different frequencies for a particular limit, what value we're looking for. So what we see here is that it takes a measurement at that frequency, and then it graphs that out here. Now we've got that lower line on here that represents the limit. So anything that drops below that limit line is a failure. And so we look along here and we say, okay, what's going on with this? Now, this is not distance. And it's really important to know, because sometimes people get confused here with looking at this and say, oh, well, where is it on the cable? I can't tell you where it is on the cable from this graph, because here we're looking at frequency and what the difference is between that limit line and the result. Now, there's a few things I can tell you that we see here. One is that our margin down there is 0.4 dB. Now, we could go in and we could look up what ANSI TIA 1152A says for what the error or what the margin of error is in here. But every test instrument has a margin of error. And let's say in this case that at this frequency, our margin of error was plus or minus 1.5 dB. What that's then saying is that if we're within 1.5 dB of that limit line, we can't really tell you it's a pass. We can tell you that it's on the positive side of that limit line. And that's why we got that pass with the asterisk and the top bar is orange, that our test result is within the margin of error of the tester. Now, we could go back and we could look at what type of tester this, is this a level 3E tester? There's certain classifications of testers. So if I'm comparing different manufacturers, if I have a level 2G, I can do Cat 8. If I have a level 2G tester, you have a level 2G tester, they're comparable. Well, in this case, we're within that margin of error. So we're so close to that line that we can't really tell you whether it's a pass or a fail. Now, ANSI TIA says there's no such thing as a marginal pass. ANSI TIA says it's a pass. But I told you that the other question I ask in addition to alien crosstalk in every class is a marginal pass a pass or a fail? Hands down, everyone that I've had in class, it is a fail. Nobody wants a marginal pass on their test results. So in this case, what we would do is we'd want to go back and take a look at our near-end crosstalk there and see. Now, the first thing I would do on this screen is down at the bottom of the screen, we see that there's two arrows next to pair. So we can scroll through each of our pairs, or combination of pairs, because that's what we're looking at with near-end crosstalk, and we can see which combination of pairs failed or was marginal. And so we may see that most of the combinations are good, but we've got one combination. And oftentimes, like let's say you're using the wrong category of jack, we're going to see that that combination is 3, 6, 4, 5. And so if it's 3, 6, 4, 5, man, I'll run straight to the jack to see what's going on there.
Yeah, and
so
yeah, the reason there's so much negativity against star pass test results, and I can say this for being an instructor for a manufacturer and also a student in a lot of manufacturer certification classes, it's drilled into your head that they don't want star pass test results.
Right.
You know, if you got 1,000 cable job and you've got 2 of them say star pass, that's an anomaly.
Right.
If you've got 100 cable project and 63 of them have star pass test results, there's a consistency problem somewhere. And it's most like, and as you pointed out earlier, it's most likely termination, or most likely installation issue, not a manufacturer issue. So let's look at this. What this result here. This is you're talking about the HDTDX analyzer, right? So what we're looking at on this screen.
Okay. So on this one, let's start at the ends. Okay. So if we look at the ends, what we see is that at 0 and at about 300, I guess it looks like about 300 feet, we're seeing that we don't have very much crosstalk at all. In fact, I would tell you with this one, and I'd need to see the whole test result, but with this one, I see so little crosstalk at each end that I would be inclined to say that this test was run with a channel adapter. Because if I'm using a permanent link adapter in that case, I would expect to see more near-end crosstalk far ends than I do. But what I do see is that out here in the middle of my cable, I'm looking at a value of 30.91. And I had mentioned before that in the cable, I don't want to see a value greater than 10%. And if we were able to flip through our pairs on this result, we would be able to see which pair combination that we're seeing the most crosstalk. So this right here is a cable problem. This is a problem where there is a significant amount of crosstalk between a combination of the pairs in that cable. And we see that along the entire length of the cable.
So this would be one of those scenarios where you would recommend replacing the cable?
Absolutely. Yep.
There you go.
And yeah, so that when we see something like that, where we have crosstalk above 10% running along the length of the cable, I would say, that could have been damaged during installation. And what I'd look at with that is I had a former student send me some results and she said, can you just look at these and tell us what you think? I looked at it and I saw that all but one of the cables, good crosstalk along the length of the cable. But there was one that looked a lot like this. I told her, I said, I think somebody was pretty hard on that cable pulling it in. They really beat that thing up there. Whether they got a twist in it, who knows what happened to it. And she goes, yeah, that was exactly what we saw. And we're just kind of testing to see, if you would see that too. But, and that's why, going back to testing some cable before you install it. Nobody wants to pull cable in to find out that it's bad. It's rare it happens. So it could just be an exercise in spooling off some cable and figuring out what your MVP is. Right. But it saves a lot of time. And so that right there, that something happened to that. if this was inconsistent with all the other cables. Something happened to that cable when it was being installed.
Yeah, if it's an installation error, not a manufacturing error, my first place I would ask is, when you were pulling this cable, tell me about the transition into the ceiling. Was it rubbing against a ceiling grid? Was it rubbing against red iron? Because it could be just like you said, a really sharp angle, and you got Bubba on the other side yanking on that cable as hard as he can. It's going to damage the cable for the entire distance.
Yep.
All righty, so let's look at this one. This is another HD TDX analyzer. This will be the last one. So when you're looking at this one, what does this one say to you?
Well, okay, so if we start on the right-hand side of that, which is the remote end, see, we do see all the pairs, and we see that near-end crosstalk jump up. So to me, what that tells me is I've got some near-end crosstalk at the far end, which I fully expect. So I would expect to see that measurement if I was using a patch cord adapter for an NPTL link or a permanent link adapter. So that tells me, one, they're using probably using the permanent link adapters for this. But if we look out there at, let's see, about 20, what is that, 24.7? I got to put my glasses on.
Yeah, 24.
So 24.7 feet, something has happened to that cable. So we're not seeing it along the length of the cable. In fact, after that point, you see that, we've got just a little bump in there, but we don't even hit 10%. But somewhere within the first 25, 26 feet of that cable, something's wrong with that cable. And this could be that, again, maybe J-hook, you can see it if somebody really cinches down cable ties. But the thing to remember is, anytime we do something to that cable that causes those pairs to flatten out and not have that twist to them, and that's another one that I always bring up, is when we look at the length of a cable, you see each pair is a different length.
Yep.
First thing I always ask, why are they different lengths? They're different twist ratios to ensure that no two conductors are always right next to each other.
Here's my interpretation of that test result. They ran the cable before the drywall was installed, and the drywaller came by and screwed their drywall to the studs, and their cable got squinched somewhere.
Yep.
That's my interpretation of that.
Now, one we ran into, because with this interop show that was on the network, more on the networking side of things, I was part of the crew that helped install the network. We'd actually, it was kind of fun. We'd go down to San Francisco for a few weeks and build the whole network, and then load it in semi trucks, haul it to Vegas, and set it up. And we got everything working, and then they came in, the people that set up the booths came in, and they put in these halogen lights. And we noticed that a few of the booths stopped working. So some of the people on our team said, oh, those halogen lights, they cause all kinds of problems. So we put it was the DTX back then, but the Fluke tester, and we noticed that we had a short, we had broken pairs, and we measured how far, and we measured it out, and it was right at one of the lights. The problem was that the lights, the cables were laying on the flange of the red iron up there. So the lighting guys came by with these C-clamps, and they just clamped it right on. They didn't look at what was on top of that flange. And they got our network cables in between. They reefed that thing down so that light wouldn't move, and it destroyed our cable. So exactly that. Something got pinched, something just wasn't quite right. But the neat thing is, it tells us to a fraction of a foot, where do we need to go to find that?
One last question. I know I said that was the last one, but I thought I had one more. And I promise this will be the last one. The heads, the permanent link heads and the channel heads.
Yes.
One of the things I had to one time create a document for our company, the correct procedure on it was a test program, right? We won a project. We had to show them we had a test management program, and so I had to go, create this whole procedure. And then the procedure, I told the technicians, when you get issued the tester, because nobody has very few people have a tester assigned to just them, inspect that tester on the permanent link heads. Look to make sure that the little tabs aren't broken off the mod ends. Make sure there's no cracks in the jackets, on the channel heads, look inside of them, make sure none of the pins are bent or mangled or have dust, dirt, debris on them and stuff. That just got me to thinking, doesn't a permanent link head and a channel head, don't they need to be replaced? I mean, you're constantly plugging in. What's the life cycle on that?
So the life cycle on the tips of the permanent link adapters is rated at 5,000 insertions. Now, we all know you've got the guy that's dragging the tester around by the cable. And, we've got these, they're actually on my cable, so I don't have any laying around here. But there's nice little plastic clips that go, that came with the tester that you can slide over that. I always try and keep those on there because the conductors are gold plated. Now you can wear that gold plating off, and if you're using it a lot, it may not impact it a lot. But if you're sitting around for a while, those can start corroding. So what I do is my pro tip on going in and setting reference, which there's always confusion over the difference between setting reference on fiber, where we're zeroing out that optical signal strength, and setting reference on copper, where we're synchronizing the main and the remote. And also it takes into consideration the temperature, which can affect insertion loss. But what I recommend to people is that, with the Fluke equipment, we take the permanent link adapter and we connect it to a channel adapter on the remote, we set reference. I always recommend that you take the other permanent link adapter and the other channel adapter, hook those up and set reference again. And so now what you've done is you've tested both permanent link adapters and both channel adapters. So when you go in and start doing your testing, you can be rest assured that both of those are working, and they're working like you expect them to. And
do you recommend that they do that?
So it is a good idea to set, because it does take ambient temperature into consideration for insertion loss. We recommend that before each test cycle, or at the beginning of each shift when you're doing testing, set reference. Leave the testers on for at least 5 minutes and set reference. Now, one of the things that I really like with the Fluke tester is you can reference one main unit to up to 8 remotes, or cool. Main units running as remotes. So you can have, if you're working by yourself, you could have a whole bunch of remotes out at the far end, test. But that way you only have one main in the wiring closet, and you're saving all your results on one unit. So you're not trying to, pull results from multiple units, and you can have people moving around with those different remotes. But yeah, before you start going out and testing, and it's that professional, this is how we're going to do that. We're going to get the right tools out. We're not going to take and plug a patch cord into our channel head and use that, move that from connection to connection. And all of that, fits in. I had somebody come back and say, these little short patch cords, thin short patch, are those bad? Well, we built a channel. We put this at the patch panel. We put a longer patch cord out at the other end. We had 295 foot permanent link, ran a channel test, and everything worked just fine. So, but those channel limits are much more relaxed because it's taking up to 4 connections into account and all that. So,
Mike, it's been an absolute pleasure, my friend.
I'm glad to be on here, Chuck.
I can see you're going to be coming back on again, because I got a ton more questions, like management of test records and a bunch of other stuff that we can hit you up with. But I've already had you for a long time. So
we've got testers here. I love to, let's hook something up and try it, right? That's the best way. And there's a term a saying I've been using for decades now, and it's stop using the S word and that should, because people, we hear it all the time. That should work. That should do it. And it's we have the technology to go in and actually measure it and see. So stop using the S word.
There you go.
Be definitive.
That sounds like a future pro tip. That's going to be pro tip 147. Don't use the S word. I'm stealing it. I have your permission.
TM, trademark Mike Pennacchi.
Pesky laws. All righty. Until next time, everybody, remember, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.